Hi, so let's look at another aspect of the Bronsted Lowry theory of acids, and that is the conjugate acid-base pairs. So a quick reminder, Bronsted Lowry theory is acids are proton donors, bases are proton acceptors. Acids leave a negative ion and produce a negative ion. Bases produce a positive ion. And the Bronsted Lowry theory, one of its big step forwards is it takes into account the solvent and thus production of hydronium ions. So let's have a quick look at a couple. Here we have ethanoic acid or acetic acid if you want, same thing, and it is the acid because it is donating a hydrogen ion or a proton to the water. It is protonating this base, and it is leaving a negative ion, and that makes it an acid. The water is protonated, or it accepts a proton, and it leaves a positive ion. It is definitely the base. Here we have sulfuric acid and water. Sulfuric acid, in this case, the name kind of gives it away, but it donates protons, 2 of, and it leaves a negative ion, a negative sulfate ion. Here, so acetate ion is negative, sulfate ion is negative. The water here is protonated, so it accepts a proton and forms a positive ion, so it's definitely a base. And here we have hydrochloric acid and ammonia. So we've gone for a slightly different example here. The hydrochloric acid produces a chloride ion, which is negative, and it protonates the ammonia, so it donates a proton. That makes it an acid. The ammonia here forms a positive ion, and it accepts a proton. It goes from H3 to H4. Therefore, it is a base. Now, basically, what we're saying here is that if you have an acid on one side of the equation, so ignoring the hydrogen that it loses, the acid molecule on the other side, it's called the conjugate base. So parent or primary acid, conjugate base. So A to A. Over here, you have your primary or parent base, and on this side, it becomes a conjugate acid. And what this means is if you reverse the reaction, and in an equilibrium situation, this makes more sense, but if you reverse the reaction, this conjugate acid over here will become the primary acid because it's got a proton here to donate. So on this side, it has a proton to donate, which makes it an acid. It has no proton to donate, which makes it a base, but it's the conjugate base. And so we have acid, base, conjugate base. This is our acid. If we follow it along, it's now a conjugate base. And this here is our base. And if we follow it along, it becomes our conjugate acid. And that's pretty rad. So let's have a look at a real world example. It's hydrochloric acid again. It's a really common one. Acid, conjugate base. Sweet. That makes perfect sense. The negative ion formed is the conjugate base. Okay, so the negative ion that we get is the conjugate base. And if we come over this side, we've got a base and a conjugate acid. Cool. The positive ion is the conjugate acid. I hope that made sense. If it didn't, feel free to ask any questions in the comments below and we'll get back to you as quick as we can. Thanks for watching and we'll see you next time. Bye now.